Okay, so we are still in the tension member. Now we will solve problem number 4.9. So this is quite a big problem that will help you how to design the tension member. So until now we just try to solve the tension member to carry the or designed the tension member to carry the force. Now we will try to design the end connection also, so that there will be the complete design for a tension member. So I will read out the problem 4.9. So again it is in for the angle or Indian standard angles. So the problem says design a tension member using two angle sections. So we have two angle sections to carry 180 kilonewton when both angles are connected. So there are again two cases. First case is on both sides of the gusset plate, and second case or the second type says on the same side of the gusset plate. So basically we have two angles, they are connected on the same side of the gusset plate and both side of the gusset plates, and they have to carry 180 kilonewton. So let's try to solve it. So let's consider the first case. So in this case the angle, that is Indian standard angle, is connected on both sides of the gusset plate right? So simply we have to follow the procedure given for the tension member. So first step, we have to find out the net required. So it will be load or the force divided by permissible stress. So it will be again angle, and we do not know the thickness of the angle. So from the table 4.1 we can take the value for the permissible stress as 150. So to calculate the net required, the force to be carried is 180 kilonewton. So let makes it Newton, and then the permissible stress is 150 Newton per millimeter square. This is from table 4.1. So this come to 1200 millimeter square. So remember that this is the area for the two angles. So our job is to now choose the angles, two angles particularly, when their area will be 20 to 40% more than this value. So try to choose it. You can choose anything. So here I am choosing two ISA 80, 50, and thickness is 6 mm. So one leg is having 80 mm length, another leg is having 50 mm length, and the thickness is 6 millimeter. So we are choosing these two angles. So the area of these two angles will be equal to 2 into 746. So area of each angle is 746, cross section area. So total area will be equal to 1492 millimeter square. So this is approximately 20 to 40% more than the required net. So once we have that, the next job will be to find out gross diameter of the rivets or the diameter of the rivets. Generally we know that diameter of the rivets is calculated as 6 square root t. So you can use this formula, or you can use another, or you can just guess the diameter, that is also okay. So if you are using this formula, that's fine, or you are guessing the diameter of the rivet, that's also fine. So I am using diameter of rivets equal to 20 mm. So only one thing we have to consider, that when we use the number of rivets using this diameter, there should be appropriate distance between two successive rivets, that is this distance, and there should be appropriate edge distance. So that is the only criteria or the most important criteria for choosing the diameter of the rivets. So we will see that how to do this in the following slides. So once we have the diameter of the rivets, so gross diameter of the rivet, I will call it GD 20 plus 1.5. So this will come to 21.5 millimeter. So once we have the diameter of the rivets and we have the A net required. Now from this calculate actual A net available. So A net available or actual A net will be equal to A net required, REQD required, minus area for rivets, right? So let's calculate this. So as this is A net required is 1492 minus gross diameter 21.5 into 6 plus 6. So these are the two rivets, and this is as per the procedure. Again you have to refer the procedure. So I am deducting the area for one rivet for each angle. So I will be deducting the area for two rivets for two angles, and this A net available will come to 1234 millimeter square. From this we can calculate the strength of the member. Strength of this double angle member, we can do ISA member when it is collected on both sides of the gusset plate. So again the value for the permissible trace is this. To make it kilonewton divided by 1000, and A net available, that is 1234. So this will come to the 185.1 kilonewton, and which is greater than required value, that is 180 kilonewton. So we can say that our design is safe or the okay. Once we determine the, so when we say it is safe, or we determine the size of the angles, so now we have the size of the angles, right? And we have rivets also, but we do not know how many numbers of the rivets are required. So we need to design the end connections. Design. For that again you have to go to this chapter number 2 on the fasteners. So for that, first of all we need to find out the rivet value, right? Rivet value. So it is nothing but the minimum force transferred by, or minimum safe force transferred by the rivets. How to determine that? So this will be in different modes of the failure. So to determine the rivet value, first of all consider rivets in double shear. Again go to the chapters on fastener, that is the only suggestion from me. So the shear strength is 100. Again to make it in kilonewton, divided by 1000, and double shear means 2 times or 2 areas of rivets, that is pi by 4 into 21.5 bracket square. So this is area of shingle shear, 2 being double shear, and this is safe shearing trace for the rivets, and this is to make into kilonewton. So in double shear, rivet value will be 72.6. so this is the safe force transferred by the single rivet. Then in bearing, so this will be given by, that is rivet value in bearing. So permissible trace 300, again this is to make in kilonewton, and this will be little different, 21.5 into 6. So this is the diameter and 6 is the thickness. So this is 21.5 and this is the 6. So it's like a crushing. That's why we have to take this rectangular area, and this value will come to the 38.7. So obviously smaller will be the rivet value, so choose rivet value as 38.7 kilonewton, right? Once we have the rivet value, the next job or the final job we can call it, or maybe third step or fourth step, whatever, number of rivets. Find out the number of rivets. So force to be transferred, that is total force to be transferred 180 kilonewton, and rivet value or force transferred by each rivet. So this will give us 4.6 rivets, so nearly or rounded to 5 rivets, right? So we require the 5 rivets. So we have the size of the ISA members, we have the size of the rivets, and then we have the number of rivets. So now final job is to draw the figure or to find out the what should be the placing or how to arrange these rivets on the or for the connection between the gusset place and the two angles. So for that we require to find out the pitch, that is distance between the two successive rivet, that is 2.5 into cross diameter 21.5. This will come to the we will take nearly about 55 mm. Then edge distance of the first rivet from the edge will be given by 2 into 21.5. so these are the general recommendations. So this will come nearly equal to 45 mm. So as we have this information, we are all set to draw the figure. So suppose this is the, let's see, this is the gusset plate, okay, and this is the gusset plate, right? This is the gusset plate, and gusset plate we have. Then we have to draw the number of rivets. So let's draw 5 rivets, 1, 2, 3, 4 and 5, and then these are the angle, right? So this is the outstanding leg, what I am drawing here, right? This is outstanding leg, and this is connected leg, right? This is on the one side and one will be on the back side, right? So they are connected from the both side of the gusset plate. So this distance, edge distance, we have calculated, this should be 45, and the pitch distance between these two should be 55. So this is again 55 and this will come again 45. One more thing we have to take, that is this particular angle and the angle on the back side. So these are called tacking. So tacking rivets. So one will be here, one will be here, one will be here, so that both the angles will act as a single face. So these tacking rivets or this kind of rivet should be provided at the rate of or at the distance of 1 meter center to center, right? So center of this rivet and center of this rivet, this distance should be 1 meter. So depending upon the length, there will be number of tacking rivets and the distance between them will be 1 meter. So this completes our design of the rivet. So we require these 5 rivets and we require this many number of or tacking rivets at this distance, and we already determined the size of the ISA, Indian Standard Angles. Also we determined the gross diameter or nominal diameter of the rivets. Okay, now it's time to solve for the second part. So second part says that two ISA, that is 2 in number, they are connected on the same side of the gusset plate, same side, and they are connected through longer leg. We know that they are uh, 80 50 ISA, so longer leg is 80, so they are connected using the longer leg 80 mm. So let's try to solve this. The first step, again it will be the same to find out the A net required. So this is again angle, so it will be the same like earlier part, 180 divided by multiplied by 1000 to make into Newton, divided by 150. So this will come to the 1200. And same like earlier part, choose the two angles, 2 ISA 80-50 and thickness is 6 mm. Now we will do little different thing, or it is done in the book, so I am just forwarding it. So choose the diameter of the rivet, dia, let's scratch this, dia of rivet. So earlier in part 1 we choose that 20, let's choose it here 16 mm. So cross diameter will be equal to 17.5 mm. This is done to maintain the proper distance between the rivets and to maintain the proper edge distances. Here number of rivets will be little bit more. So next job is to find out the A net. So we already find A net required. Now we have to find out A net available. 2 into A1 plus A2 into K2, right? So this is for two angles, A1 plus A2 into K2. This is the first standard formula, and K2 is equal to 5A1 divided by 5A1 plus A2. So to find the K2 we need to find out the A1 and the A2. Again, for the legs of the angle the formulas are same. A1 will be equal to, this is for the connected leg, right? So 6 mm is the thickness, this is the length of the leg, that is 80, then gross diameter, okay, subtracting gross diameter and then subtracting t by 2. So this will give us value of A1 as 357 millimeter square. So this is your A1. Now find out the A2. This is outstanding leg. So simply 6 will be the thickness of that leg, 50 is the length, and minus t by 2, that is 6 by 2. We don't have to deduct gross diameter of the rivet because it is not connected. So this will come to the 282 millimeter square. Once we have these two values, find the K2. So as I already mentioned, K2 will be equal to 5A1 divided by 5A1 plus A2. So this will come, if you plug in the values, and you will get this K2 as 0.863. So this will help us to get our required value, that is A net, because this is required, A net available, this is not A net required. We already find out the A net required in the first step. So that is approximate value, and that is 20 to 40% more, and calculated using the force or the load to be transferred and the permissible trace. So now this is A net value, that is available value. So it is different that A required. So don't confuse between them. So 2 A net will be equal to 2 into A1 plus A2 into K2. This is standard formula when two angles are connected on the same side of the gusset plate. So just plug in the values, you will get the A net, that is 1200.7 millimeter square. So this is slightly more than what we calculated or what is required, that is 1200. So we are good. It is on the edge but slightly more or equal to that, so we are good. So our design will be the safe, right? This is okay. Now we have to find out the, so if it is more than that, definitely the force transferred will be more than 180. It will be slightly more than 180, so we don't need to calculate that again, or we can calculate, you can calculate if you want. Then next part is to find out the end connections, right? Why we are doing this? Because we have the size of the angles ISA, we have the diameter of the rivets. So our job is to find out now number of rivets, that is, and for that purpose we require to find out the rivet value, the same what we did in the part 1. So rivet value. So here as this angles or ISA, two ISA are connected on the same side, two ISA are connected on the same side, so we need to consider a single shear value, or only one rivet will fail first, and the area, corresponding area, will be pi by 4 d square. So there will not be double shear because it is not connected on the both side, they are connected on the same side. So so rivet value in single shear we need to consider single shear, so will be equal to, so this value will come equal to, again for the shearing it is 100 to this make kilonewton divided by 1000 into pi by 4 into d square, that is 7.5 square. So this is again single shear, you have to remember the difference. So this value will come to 24 kilonewton. Then second we have to find out the rivet value in bearing, and then take the minimum from these two. So as usual, this is permissible bearing trace, then this is to make into kilonewton, and as I explained earlier, this will be 17.5 the diameter and the thickness, so it is like crushing, and this bearing value will come to 31.5 kilonewton. So minimum of the two will be the rivet value, so rivet value will be equal to earlier, that is in shear, single shear, that is 24 kilonewton. So from this we can find out the number of rivets. This is the sign for number of rivets. So this is 180, this is total load to be transferred, and this is rivet value, that is force transferred by each rivet. So this will give us number of rivets required 7.5, so round it to the next higher value, that is 8. So we require 8 number of rivets, right? So we have this now, we have the size of the ISA member, we have the diameter of the rivets, we have the number of rivets. Now to draw the figures, find out the pitch of the rivets, the same 2.5 into gross diameter, so that is 17.5. so this will come to 43 point something, so let's make it 45, right, near about 45. Then edge distance, so this will come again 2 into 17.5, so it comes exactly 35, so keep that as it is, so 35 mm. And then we have to provide the taking rivet or tacking rivets we explained already, so that will be at the distance of 1 meter center to center of these rivet. So we have all the information to draw the figure. Let's draw the figure. So this is let's make it little bigger. So this is very big gusset plate, right? And so we have these two ISA or Indian Standard angles connected to the, so this separates two of them. So this is outstanding leg for the first, and this is connected leg, right? Now this is the outstanding leg for the second one, and this is connected leg. So this is the separation line or connection line between the two, right? This separates the both of them. So we have the 8 rivets. So let's use 4 for the one and 4 for the second, right? I'm sorry, it should be like this. Here edge distance should be 35 and the pitch between successive two rivets should be 45. Here I did miss little bit, but it should be about 35. So this will be again 35. Right from here this should be again 35, and this distance is equal to 45. So taking rivets will be there from, so this is first taking rivet, this will be second taking rivet, and so on. So distance between the centers of these taking rivets will be at the rate of 1 meter center to center. So we believe we have everything. So maybe we have this kind of taking rivets. So distance between them or their center should be 1 meter, and they will keep these ISA together. So we have everything. Now we have the size of the ISA, right? Indian 2 number, that is 50 into 80, 6 mm thickness. Then we have the diameter of the rivets 17.5, that is gross diameter. Then we have the number of the rivets, that is 8, and then we have this figure that shows uh, how to connect it to the gusset plate, right? So I believe we have everything and we are good with this problem. Thank you.